to Sheet Metal Beyond the Bend, a SOLIDWORKS 2021 launch webinar series. Today, we will be showing you what's new in SOLIDWORKS 2021 sheet metal, as well as tips and techniques not often associated with sheet metal. Presenters, Wesley McMurtrey, a certified SOLIDWORKS application engineer out of our Tulsa, Oklahoma office. Me, I am David Cersley, a certified SOLIDWORKS application engineer out of our Austin, Texas office. And we are honored that you took time to join us today. Who we are. At GoEngineer, we are nearly 300 employees and a growing company. 40% of our 300 employees are certified technical specialists. We have 25 offices across 14 states. Who we serve you, the customer. 2/3 of our business employ 50 people or less, and a quarter of those organizations employ 5 people or less. Now, let's dig into what's new, tips and techniques. Wes, take it away.
Thanks, David. This is Wesley, and I'm happy that you're here with us today. I would like to take a few minutes covering some sheet metal topics with you. When designing sheet metal parts, we have long been able to create an edge flange on curved edges like these on the right. But we had limitations for curved edges originating from planar faces. Now, in SOLIDWORKS 2021, edge flanges can be created on curved edges originating from non-planar faces such as those in the bend area. The preview shows how the edge flange will be created all the way around the part. Familiar flange customization tools are available to help define the edge flange, such as length, angle, flange length, dimensioning method, and flange position. This new edge flange looks great, and I'm sure to provide more stiffness to the angle bracket. And of course, this edge flange can be flattened, ready to be detailed, or exported to DXF for fabrication. So let's take a look at it in the flattened state. So rotate it around, take a quick look at it. Looks good. And we'll go ahead and say, we're going to take a look at it first though with our bend lines shown there. So our bend lines looking good. Let's go ahead, get out of that state back to the bent shape with edge flanges included there. So pretty nice feature to have there in 2021 coming up. And we'll go ahead and take a look at it as it's exported DXF as well. As soon as we can find it, there it is. And let's go ahead and click on save. Select a few options there. We'll include bend lines as well. We'll say OK to that. And preview of our DXF export. Now let's take a look at an assembly that has a sheet metal enclosure. This edge flange is great for structural integrity, but is also useful for enclosure and guarding such as this cover. So let's take a look at modifying this existing design. So the edge flange on the far side needs to be modified to protect the components of this navigation control unit. So we have all of our options available for control, making changes, overrides. So if we wanted to change from 90-degree angle to 45, reverse the direction to have our enclosure come out the other direction and down, possibly creating a safer environment for what's inside the enclosure. All of those things are optional. If we want to, we can also go and open the part, and let's take a quick look at it in the flattened state as well. So yeah, it's a very useful tool. A lot of our customers have asked for this, and I'm glad to see this coming up in 2021. Definitely something that could be useful to a lot of people. So up next, let's go ahead and take a look at another part that I created using the edge flange techniques that you've just seen there on a non-planar or circular edge. And what I'm going to do next is I'm going to create a new sheet metal part based on the profile or outline of the existing flange. And what I'm going to do is Go ahead and go to my sheet metal command and select base flange tab, and we're going to build off of what we've already created there. So nothing very specific here, just a distance there. We'll say 4 inches. We'll call that good and say OK. What I do want to show you is that that there's a lot of controls with the function called tab and slots. So let's go take a look at our tab and slot feature and show you a little bit of the capabilities it has as well. So this is still fully featured even with the new edge flange being introduced in 2021. As you notice, I'm going to walk around the part here, create a new group for my next set of tabs. Zoom in just a little bit to grab that edge. I've got 2 slots now. I'm going to change that to 3. Repeat again, new group. Select an edge, the face that we want our slots to go through. Just kind of walking our way through the part. Again, like what we see there, looks good. We'll say new group, our final group here that we're going to work on. One last edge and one last face. And let's knock that back down to just 2 tab slots in that section. And we'll say OK to that. So, pretty useful tool there, the tab and slot feature. You know, a part like this, if you were making this, these tabs and slots would definitely help hold the part together, perhaps while a welding operation is taking place, or who knows what purpose that may serve. But that's definitely one of the purposes for a tab and slot is to locate and eliminate, or at least reduce the number of fixtures and tooling that may be required to hold something together while it's being manufactured. So you can see here we have a couple of flat states there. There's the first flat on one of the bodies, and then the second flat indicating the tabs portion of the body. So definitely handy tool. I wanted to show that to you just while I had you here, looking at the what's new stuff. Just kind of a reminder that there have been several enhancements in previous years with tab and slot, and some of those things have rolled over into 2021 and still are still very handy. So let's do one last thing, and just for fun, let's go ahead and mirror this part, and just to kind of get a look at the mirror function here, and just to kind of throw this thing out here. Who knows what that might be, but anyhow, kind of cool. Thought I'd throw that in there. One more thing I would like to show you before I turn you back over to Dave is the ability in sheet metal, or in SOLIDWORKS sheet metal, to convert bodies to sheet metal. Sometimes there's instances that may arise that you may need to convert a body back into sheet metal. So what we have here is a piece of angle iron, or what would be considered angle iron, I guess you could say. And then what we're going to do is we're going to take this and we're going to convert that into sheet metal. So we'll go to our sheet metal tab, and we're going to select convert to sheet. And let's go ahead and select there. And to do that, we'll need a couple of things there to select from. So we're going to select on a face that we want to make fixed, or a fixed entity to build off of. So we'll go ahead and select this face as our primary. And let's go ahead and look at some of the different parameters here. One, we just our thickness. We can reverse the thickness. Our bend edge there is set at 1/8 of an inch, and we're going to select this as a bend edge. Let's go ahead and click on that. You notice there our previews pops up, and we're starting to see beginnings of a model there, our sheet metal property there. We still have our, in gray there, our original body. Let's go ahead and say OK to that. And let's take a look again at what we've got there. And I'm going to suppress that back, or roll back. Take one more last look at that, at our original body. And I'm going to measure my thickness there. My iron angle was actually 0.175. So let's go back and let's change that back to, we'll go back and edit that feature that we just created. Let's change that now from 0.1875. We're going to override that and change it to 0.175. Give us the correct thickness. And now you see we've got a preview there of a part that's the correct thickness, or at least based on our original body that we're working on. So you notice now we've got all our slots already made up for us, that found out everything that we needed there in the conversion there. So I'm going to go ahead and hide the original body so I don't have to look at it anymore. Now we see we have a true sheet metal part that we can flatten. So now we can take that out. We have a piece of metal in the shop, cut that out, put a break in it, and voila, we would have a part that would at least overcome maybe the possibility of waiting a few days for metal to come in, or who knows, whatever the reason it may be. But in this instance, let's just pretend that we've ran out of angle iron and we need to get something done, and the deadline's approaching. So this is our best course of action. We just converted it to a piece of sheet metal, but we do still need to add some gussets for rigidity. So we can do that in the weldments section here. So I'm going to add a few gussets. Start there, we'll be fine. Maybe change a few parameters from 1 inch distance to 3/4 of an inch. And maybe make it a little bit thicker, even thinner. Or if we need to offset it, we could use one of those buttons. We'll go ahead and say okay to that. And we'll do the same. We'll put a couple more in here. And so select our gusset feature, select a couple of faces. And you notice there on the end, we have a new tab, or new gusset, sorry, not a tab. And let's go ahead and place that using an offset. And we'll just bump that over until it looks like something what we might want there. And we may make that a little bit shorter just in case there's a washer or a screw that gets in the way, or we don't want any interference there. So let's change that. And we'll add one more just for good luck. One more gusset there. We'll put it in the center, or offset it there. 9.5 is what we're set. Let's go ahead and bump that over the other way. So we're offsetting that from center. That looks fine. Take a look at everything else. Maybe we can make this a little bigger. We'll change that so we don't have 3 different sizes. We'll ahead just have a 0.75 and a 0.5, and then we'll say okay to that. Now I do need to go in and take care of one issue that I do see here, and that is the corner of my gussets there. So I'm going to add a chamfer on each of those corners there, and go ahead and select and use a chamfer fly out toolbar there. Will work just fine. We'll go ahead and walk through here one more time on that one, and once again, the third and last, we'll go ahead and add a chamfer. Okay to that. Now let's go back and unhide our original sheet metal part there. Now we see within just a few minutes we've converted that angle iron piece over into a sheet metal piece. Now we're ready to take this back out and perhaps get this thing made out of sheet metal today, and carry on from there. So you notice now back to our sub-assembly that this originally came from. We'll go ahead and say yes to that. Let's go ahead and take a look and zoom in here. So without any issues, we basically have converted a body to a sheet metal part just like that. Dave, I'm going to hand this back over to you. And for everyone that's out there, I appreciate you sitting through and listening to me talk about what's new and some of the enhancements, and listening to new tips and techniques with sheet metal.
Wes, thanks so much. That was really good. Now I want to show you a few techniques that were results of recent calls. The first being, how do I get or create a multi-body part inside of sheet metal and then get the flat patterns out? There's a couple ways. Let's explore one of them. So here we have an assembly with all of our parts on our table. Let's dig down and look at the table. To understand how we're going to get our sheet metal flat patterns of each individual part, let's take a look at the part itself. Here we have flat pattern. Underneath flat pattern, we can see that there are 5 parts. If I hover my mouse over each one, you can see that they highlight on the screen indicating which part is that flat pattern associated to that part. Also, under cut list here at the top, we have like tabletop, front leg, right leg. Now, let's take a look at our drawing. We're going to open up our drawing, and here we can see that item 1 is the tabletop and item 2 is the leg, and we have a different leg over here. So, how do we get these flat patterns from this multi-body part into this drawing? One way we can do that is model view. Here in the open documents, we're going to pick on our sheet metal cutting table. We're going to click on the blue arrow next. Here we will select the box called Select Bodies. And when we do, this will take us back to our part file. When I pick on one of the parts or one of the bodies, it will populate in scope. I'm going to hit the green check. And when I hit the green check back over here in my drawing, I want to pick on this button here, Flat Pattern. So I pick Flat Pattern. I'm going to simply left click over here on my drawing here in just a second. And I'm going to place that view here. And we can see that we already have our bend lines. We have one for the foot and one for the leg itself. We're going to hit OK. Let's do this again, and we'll do it for the tabletop. Model view. Again, make sure that this is the part we want, and this is our cutting table. We're going to hit the next arrow. Select bodies. And when we go back to our part, we're going to select the top. Make sure tabletop is populated in scope. We're going to hit the green check. I'm going to make sure I have flat pattern selected. And over on my drawing sheet, I'm going to left mouse click to place it. Give me a preview of my part. And I'll second left mouse click again. I'm going to hit the escape key one time. And if we zoom in, we can see now that we have the bend lines and the flat pattern for the tabletop. And we can keep doing this for each one of the individual parts. So that's one way that we can create a multi-body part and then get those flat patterns into our drawing. Now let's take a look at a little bit more of an advanced sheet metal part. This part, in this scenario, we are going to take this part here. It's a flat pattern. And what we want to do is we want to create a wrapped part. We want this to pretend it's going to form around a mandrel, and we're going to leave a little parting line so that it can be welded. If we look over here on the left, we can see that we started with a part, there was a seed, and then it was patterned. And now what we want to do is get this into our formed shape. And to form a round shape, one way you can do it is with the flex command. Now, in sheet metal, or you can just search up here at the top of your screen. I already have it saved. There's flex, F-L-E-X. When I activate flex, it's going to ask me for my input. I'm going to select this inside or this top face. And I'm going to set my degrees to 359 degrees. I want it to almost go all the way around. Not totally, but I know that I want to leave a little gap for a weld. Here, under my triad, I'm going to set all of these to zeros. These first 3 position the triad, and then these allow for taper or a draft in each one of these axes. I'm going to leave my flex options kind of set low for this demonstration, so for the sake of speed, and I'm going to hit the green check OK. And here you can kind of see that it's already starting to preview. And it also tells you your trim planes, and it also tells you your bend axis. Now what's it's going to do is it's going to take that part, it's going to wrap it, and now what we have is our part. And we have a little weld line right here. So the thing I do next is I like to create a configuration in the formed state and in a flattened state so that if I need to get a DXF, I can. I'm going to hit the configuration manager, add configuration, let's call it formed. I'm going to make sure suppressed features is checked. I'm going to hit OK. I'm going to pick it again, and we'll add another configuration. We'll call it flattened or flat. Again, make sure suppress features is checked. We're going to hit our green check OK. And all we have to do now is go to our flat configuration, go back to our feature tree, suppress that flex command, and now we have our flat pattern that we could just click on and save it, export it out to a DXF, or we have our formed part that is ready to go off to weld. Now, lastly, is this advanced flatten situation. I recently got a part close to this, and the customer's like, Dave, what we need to do is we need to get this shape of this metal in a flat pattern, and how can we do that from this shape? Inside of SOLIDWORKS Premium, you have a feature called Surface Flatten. Now, this part has already had flow analysis. We've already run simulation on it. It's ready for production. Again, all we need is the flat pattern so that we can put it on the plasma cutters. I'm going to go over here to Surface Flatten. And when I pick on Surface Flatten, it's going to ask me which surface do I want to flatten. So I'm going to select the outside of my part. I'm going to go to this little box here. It says vertex or point. I'm going to select that box. And I'm going to pick this point right here. Boom. And what I do is I'm going to leave my accuracy set to low for this, for the sake of speed. And I'm also going to uncheck mesh preview. And now what the software is doing is it's looking at all those surfaces and it's trying to create the flat pattern based on its shape. So this will take just a second. To flatten itself out. If I zoom out, we can see that we now have this flattened part based on the shape of this cone-like feature. But I want to get this surface into its own file. And what if I want to thicken it to 60 thousandths thick? And then I want to create my DXF. SOLIDWORKS makes this real easy. So I'm going to go over here to my surface bodies folder. There's surface flatten. I'm going to right click on it and I'm going to select insert into new part. Over here on the left, it's going to ask me which surface or body. We've got our flattened surface. We're going to hit green check OK. And when we do, it's going to start to create our new file. Hit yes here. It's going to ask us for a name. Let's put it in the advanced flatten folder, and we'll call this test. Test 2. We'll hit save. And when we do, we now have our part. I'm going to pick on this face. I'm going to hit normal to, and there's our part. And I'm going to come over here and I'm going to do surface. I'm going to do thicken. I'm going to select the parameters. I'm going to pick my top face here, and I'm going to thicken this by 60 thousandths of an inch. I'm going to hit my green check OK. So now I've taken that surface, I've brought it in from the other file, and I've also thickened that part 60 thou. So if I hit the space bar, I do normal to again. Now what we want to do is we want to create our DXF from that. So let's do file. And we're going to make sure we save our part. Hit save all. And then we'll do a file. Save as. And we're going to make sure we save it as a DXF. Test 2 DXF sounds good. Hit save. Over here on the left, I'm going to make sure it's in the annotation view, and I've got it set to the current view. And I'm going to hit my green check OK. And SOLIDWORKS will begin the process of converting this into a DXF. And there's our DXF that I can send over to the plasma. I can hit save, and we're all set and ready to go. That wraps up our What's New tips and techniques for sheet metal inside of SOLIDWORKS 2021. please take the time to visit our other upcoming 2021 webinars when Tony Riggs on October the 27th will present Do You Mesh Well with Others? Using Mesh Data in SOLIDWORKS. We want to thank you for attending, and we want to hear back from you. So please submit or your feedback or your questions to dlove@goengineer.com. We will be giving away 3 Amazon gift cards at random. So please let us know what your favorite feature or tech tip of the day is. And you can submit your answers on Twitter or Facebook or use the hashtag GoEngineer2021. Please stay in touch. We have a couple ways to do that. We want to hear from you. So sign up for our newsletter at goengineer.com. You can also visit our website. Our newly redesigned website has all the places and information and resources that you need. So please go up there. You can sign up for the newsletter there. You can sign up for online classes. And we also have a YouTube channel which has close to 2,000 videos dedicated to SOLIDWORKS and hopefully helping you. And you can also follow us on social media. On behalf of Wesley, McMurtrey, and myself, we want to thank you for attending today. We thank you for being here. Now go engineer something amazing.